Hi, so I will be presenting my Group 9 presentation, which is RBZ, or short for Agentic Resource Manager Scheduler and Explainer. So the problem that we address is that most distributed systems often struggle with deciding which node should run which job, and most schedulers give little visibility into why those decisions are made. So our RBZ will solve this issue by intelligently assigning jobs or explaining the reasoning behind each decision. And so here, if we go to our page, this is our main dashboard where we display everything. All the nodes are available here. All of our nodes are running on AWS EC2 server, which are only the nodes are only created by the admin user. So a normal user won't be able to create any nodes, so they will be just using these nodes available here. And here we only display all the necessary stats, resource utilization, number of average latency, and all that stuff. And if you go to our node page right here, we can see a list of nodes that are available right here. And you can choose the nodes you want to connect to. So for example, you choose node 1, 2, and 4, and then you can create a group that's specific for a job. So maybe you can do like machine jump or something like that. And then you save the group, then you choose all the nodes. Here I've previously created some nodes already, some groups already. So if you go to the mesh, it can visualize for you which nodes belong to which kind of job. So as you do a lot of jobs, it will get a little bit more confusing. So here's how you can navigate around the jobs. And here, system logs is just to display all the things that is going on in the system. You can clear it. And here is a simulation page, which is the most important page that we have. We'll have the manager agent that will be responsible for delegating the tasks to the nodes. And then it will also be responsible for learning which policy is best given a goal. So here you can kind of choose the learner, so which like the learning algorithm that you want to use. And here the list of policies are available to choose from. And so we can start our simulation. So as you see, if we start the simulation, it will start sending in the jobs, and then the manager agent will delegate the jobs to the nodes. And you can see that it's switching its policy. So it's learning to best optimize the goal that we chose, which is mean latency in this case. And sometimes if you don't understand how it is switching policy and how it's helpful to the system, you can go down here and then you can click on expand with Gemini. That will capture the latest change in policy and will explain to you why such change in policy will be helpful to the system. And here down here, there's something that we can use to stress the system a little bit. So if we turn on this thing and we stress the system and set in multiple jobs, and we start stressing out the node to see how it's operate under a very stressful environment. Here it will display the leaderboard and show which policy is best for a goal given a certain behavior of uploading workload. And here we can also send in our specific jobs, such as perhaps we can send in like a test.py job, and then we submit the job. Go up here, you can see that's queue, and then it will start running. So if your job is going to store anything or display anything, it will be stored on the nodes that store on the server itself. So as a job finished running, it will log off the completion process. So we stop this and we stop the agent. We reset it. All things will reset, and you can choose a new learner to choose from. And if you go to the profile page, you can see that these are the agent that you have trained. And once you reset everything, the agent itself, all the things that it has learned will be stored and will be staying the same. So you can reuse it again. And so that's the end of our presentation. Thank you.